Hello, welcome back to my bench. Today I just wanted to jump in here with this quick one, guys. This one drove me crazy. I started to record it, but then I got trapped in the rabbit hole and went round and round and round and round and round. It drove me nuts for the longest time. And I wanted to show you what I came up with so you can have an understanding of never take anything for granted. Ever. If you're in electronics, you don't do this to keep your heart rate down sometimes, I'll tell you. What I have here is a Dorrough loudness meter. One of these guys. This is 4 of them. They're all identical. 4 little sections, all in a row. And each one of them has 3 cards on it. You got a power supply, the board that does all the work as far as amplification and stuff, and this is also the power supply is also the input board, and then you have the digital display board down here for the LEDs that go around, which I'll show you real quick when we get to that point. My problem here was that I had, out of these 4, I had one that was working, which is this one with the little notch on the side here. And I have 3 that aren't. They're drawing a lot of power. Now, I went through real quick with my measure voltages and came up with I don't have the voltage I'm supposed to have out of a particular chip. I'll show you on the schematic here. The chip I'm talking about is this guy right here. It's a 7662 negative voltage chip. You put in a positive voltage and it makes a negative voltage for you. I didn't know these things existed. They're kind of cool, but they're from 1990 something, you know. You can still buy them. By the way, this thing is marked 0698. This was made. It took me literally forever to find even a schematic for it. Even that schematic is not correct. It's okay in a lot of places, but it's not right. Anyway, the problem I was having was that when you turned it on or gave it power, the meters would go full on. Get rid of the thing here. The meters would go full on like this and stay there, all except for this one, which it would bounce up and then come back down, and it would respond to an input. So I started measurements, and measurements led me to, on the schematic, again, I had my 12 volts going in. If you look at it, you've got a 7812 right here. The output of that goes up to here. And then it goes across. It goes out to your main 12 volts, but it's also got a little dot there. It comes down to pin 8 on this little chip, this 7662. Other voltages are derived for stuff around here. I mean, you've got other voltages, and all of those were fine. As a matter of fact, this 12 volts was fine. So I read about this 7662. It said that the capacitor, this one up here, this C78, which is going to be that one right there, has to be a low Z type, 10 microfarads, 16 volts, and the output over here has to be a low Z, 100 microfarads, and that is right there. 100 microfarads at 16 volts. All of those turned out fine. This diode here is fine. Problem was my V out, I had nothing. Well, a little more looking around on the data sheet on this thing. You don't even use pin 7 or this pin 5 or pin 1. All you use is, 8, 2, 4, 8, 5, and 3. 3 is grounded. However, on the one that was working on this pin 7 here, I had an oscillator. About 10 kilohertz, it was working fine. Pin 6, it didn't have anything but some voltage on it. But on pin 5, I had no minus 9 volts at all. And the minus 9 volts is used to drive all of the op amps. All the op amps in this are plus 12. If you can see, plus 12 minus 9. For all the TLO 74s and stuff. Plus the 5 volts for other things on here, which is derived elsewhere. Anyway, so I went through this thing going crazy. I replaced, or swapped, because I don't have them in stock. I swapped out this 7882, the 12 volt, this 12 volt LM7812. I swapped out this 4575, 5 volts. It's fine. Everything's good. I was just grasping at straws until I finally just started doing resistance measurements. Now let me show you what I found resistance-wise. So let's get the meter up here. All right, there's my meter, and I'm in ohms. Let's take this good one. I know it's good because I marked it here. This is the one that would drive everything just right, and it worked. And we're going to take some measurements, basic measurements. The first one we're going to read is just the input to the input of this, and it's good. To the output of this little chip, it's about 6.5K, somewhere around there. Yeah. All right, that's fine. We go over to this one that doesn't work. Input, if I can get on it, is good. Output, it says 14K. That can be a lot of things, the inside of this chip. But anyway, there you go, 6.3. Get on it and it works better. So basically we want to make sure that we're getting our voltage over to here, which comes off of the 12 volts. This is what I went through. This is the logic that I went through to get here. Input, output, ground, 7812 to my 12 volts here. And I think, yeah, there we go. Input, ground, output is 0.2 ohms, so I've got my 12 volts going into this little chip. Same thing on the one that doesn't work. There you go. All of my voltages were right. I mean, everything was right except for the output of that pin. And I checked it, and the one thing I wasn't getting was the oscillator on pin 7. So I started doing some measurements on just resistance measurements after a long time of beating myself over the head. So I went from ground, which is here, to the oscillator pin. If we look at that, we're looking at open. Okay? Ground pin 7 or 6, it's open. That's on the one that works. Let's go to ground to pin, on the one that doesn't work, ground to pin 7. I got varying between 1 and 3 mega ohms. And pin 6, I got about a mega ohm. If we go over here, just onto the chip itself, where the chip's at, measure between pins 6 and 7. Nothing on the good one. It's open. I mean, there's no chip in here, and these are not connected to anything. Over to here, I got 8 megs, 8 mega ohms. I want to show you what happened. This, I mean, just wow. Let's get the scope up here. All right, there's the scope. We'll go over here. This is the one that works. It's got my mark on it, and we'll take a look at its where that chip is. Get it here. If you look at that, there we go. Nice, huh? Now you remember this thing's been working since 1998 or so. Pin 3 is ground, which it is. The whole top of this thing is a ground plane, and everything looks pretty good. The bottom of it, focus a little bit. Thank you. All good. All good there anyway. And all good there. Like it's supposed to be. Now let's take a look at the one that didn't work. Alright, so here's the focus. Here is, if I can find it, my chip. Look at that. Look. The ground plane is offset. Look how close those pins are to the ground. I mean, look at this. And if I measure, like we showed you, it was 10, about 3 or 4 megs to ground. Alright, so what I'm going to do, I'm going to hook up this other one. I'm going to hook up this other one here, and we'll take a look at it. Bring the meter up, put it on volts, get my leads. Here's my power. It's just 15 volts. Put my chip in here. This is the little 7662 chip. Put that in there. Positive on these. If you ever find one of these things and you want to work on it, more power to you. You want to, I don't know, get a hold of me if you need a schematic for it or something, because they're really hard to find, and when you do, like I said, they're not always right. But finally found out that this thing runs on just regular 15 volts because it's deriving the minus here for the op amps. B plus 15 volts goes there, and minus goes here. Draws about 20 mils in standby. Let's get the voltage here. Ground is okay to take off of this thing here. And we'll go, here is my input, 11.9 or 12 volts. Here is my output, 0.6 volts. Alright, so no, it doesn't work. I don't know this either. I'm going to investigate this with you. So let's pull this chip out of here. And let's do some resistance measurements on this one. Here is pin 6 or 7, which is the oscillator. Here's pin 6, which is not used for anything. So let me get the scope going here, if I can. I got a heck of a lot of things all running at the same time here, folks, so forgive me. I wasn't really ready for this. I really wasn't going to do this one, but I thought somebody's got to know about this. This is ridiculous. So let's gotta go turn on the scope. Ba-lunk. Bump-a-lump. There we go. Okay, scope's on. But all I want is channel 1. Let's get the scope up on the screen. Hook up power again. And make it stay there. And we'll take a look at our oscillator, which is on pin 7. We got about 6 volts and no oscillation at all. So let's take this off of here. And see if we got the same problem. I don't know. I could be completely wrong on this. I know that that's the problem with that one. What I did to prove it is I took one of these chips, one of these 7662s, bent the legs out, completely disconnected them from the IC holder, and it started to work. So let's take a look at this one. Come back here. What'd you throw it away for? Let's get this one under the scope and see if it's the same problem. I mean, if it is, I'm going to be very happy. I'm also going to be extraordinarily pissed, because this is just wrong. How could you let something go like this? Where are you? Okay, you're all the way up there. Yes, sir. Yes, sir. Right there and there. Okay, sorry about that. Doorbell rang. It got some parts in from DigiKey for stuff that you're going to see later on. So yes, same problem. Same problem. Now, my problem. How's the best way to fix this? Well, that's ground. Okay, that one is awfully close. That one, there is separation there. I can see it. That one is the problem. Those two. I wonder if I could just get a knife. An X-Acto knife. And cut them away. I don't know. We'll try. Okay. I think no, I don't think I'm actually going to be able to cut those away very well. Well, since they're not used at all, I'm going to have to think on this for a second. I'll be back. It'll only be microseconds for you guys. All right, let's Let's give this a try. See if I can get some backlight or something for you guys so you can see what's going on. I don't know. Rather difficult without blinding myself. Maybe. I'm going to see if I can just scrape the pad off there, since it's not used anyway. No. Isolate it. That way. And that is really thick, man. Now, there's nothing I can do about these guys, so I'll tell you what I'm going to do. This is going to be cheating, but it's just not. Okay. So what I'm going to do, let's see, let's get rid of the scope. Yeah, here's what I'm going to do. I'm going to cut the legs off the socket. I wonder, just for fun, if I just scrubbing around on that thing, if I did any good. Where did my other lead go? There it is. Give me a ground to here. 14 megs, that could be me. No, it's still 9 megs. And 15 megs. Alright. Let's see. Oh, blinking phone. Let's see if this works. Sorry about the phone. Nothing I can do about it. I'm sure it's somebody wants to, if we want to sell my house, or recently it's been, you want to sell my daughter's house. Alright. 14 megs, 7 megs, and 5 megs, whatever, isn't enough to bother voltage. But it definitely was enough to kill that oscillator. The oscillator in these is internal. And evidently extremely high impedance. Alright. Sockets back in. We'll take this one that I bent the legs back on. Bend them back down again. Put it in here. All right. Get the scope probe. Power. Bring the scope up. If I can find it. There's the scope. There's pin 7. If we come up with an oscillator, then it will probably work. No. Let's check our voltage. I might have to come up with some completely other means of doing this. If we have 11 volts, I don't know if I can see the scope on this or not. I'm not a big fan of digital scopes, by the way. They're okay, but they sure don't take the place of a real one. Let's look for 11 volts. Approximately 11 volts here. We'll take that off of voltage or put it back on voltage. No, we don't have voltage. Okay, did I even get that in there okay? We'll reseat that thing and see what we got. This is quite irritating. No. None. Do I still have resistance between those two? Oh. This should be completely open. And it's not. Did I just not cut the legs off far enough down? Gotta wait for this to heat up again. This has been aggravating. You just don't really expect this kind of thing. Tell you what, let's just for fun, let's pull these two legs out again. Stick it back in here. By the way, I have a couple of these chips that are bad because of this. Something took them out. I'm not really sure which. So, voltage. Meter. And check our voltage here. Yes, minus 11 volts. So evidently I just didn't cut it off enough. So let's take our scope and try it out and see what's going on. There's the scope. There's pin 7. Yeah, it's... Let's see. No. I'm going to plug this in my other scope, see if I can see it on here. Evidently it's working. There's 11 volts there. Let's, okay. Hang on, let me get something set up here. That's why I don't like digital scopes. I'll be right back. Unfortunately, I lost the video for this next bit, but this is what the oscillator looks like on pin 7 when the chip is working. Again. Alright. Okay, I'm back. I got everything put back together. I cut down the legs on the thing here to see if that would work. It did not, because I couldn't get them close enough. However, I drilled out the holes. I just took a little drill and drilled out the holes. So now let's hook this thing up. This is one that was not working before. Still not working. Oh, that's that one. Okay. Yeah, I don't have a chip in that one. Okay. So what happens when you connect it? Make sure I get on ground here. It launches and then goes back down again. That's exactly what it's supposed to do. But now I want to see. I want to put some audio into it. So that would be, I believe, pin 5 and the ground. Yep. And let's take a look at, well, maybe not 5, maybe it's 4. Oh, hold on. Huh. 1 volt. Oh, there we go. All right. So there's my input. Let's do this with the, what am I looking for? I want to do this with the function generator. All right, there's the function generator. Let's take the voltage away. Down it goes. Peak detect went away. Let's take it to 3. Up it goes. Back down it goes. 4 should be buried. It is. Oh, 20. 20 should knock it nuts. There's 2. That's good. Alright, so that is working the way it should work. And I just drilled the holes out and got them away from themselves. It's working. So if you guys come across this kind of thing, there's a lesson for you. I mean, just good visual inspection. But that doesn't even count as a good visual inspection. When you have to take off a IC socket, look underneath it to see if the board was printed badly and the pads are too close to the to the ground plane. That's a little out there as far as troubleshooting goes, but you never know what you're going to find. Sometimes it's rather interesting. So, anyhow, there you go, guys. Dorrough. This particular one, I believe, is a 10A. There are all different versions of these, and a dozen different schematics and different ways of hooking them up. And the only manual I could find for this one had a built-on power supply, and this yours doesn't. I mean, the power supply is over here, and the inputs are over here. This jack that is talking J1 isn't talked about anywhere in any of the manuals, period. I just got lucky and found the one that looked like it had the most correct, and got it done. So, anyhow, hey, thanks for stopping by, guys. I hope you enjoyed this. If you did, give it a thumbs up for me, and don't forget to subscribe. And if you would like to, you can go over to Patreon and support me on Patreon. That would be wonderful. So I can keep doing this kind of stuff. And because I love doing it, and I love showing you guys really weird stuff like this. So, hey, till next time.